In today's tutorial we will discuss the synthesis of paracetamol. Here we have its structure, we have the acetylated amino group and this free phenol. And recently I was asked why the acetylation of this parahydroxyaniline takes place exclusively or almost exclusively at the nitrogen. Well, the simple answer is nitrogen is less electrophilic compared to oxygen. Therefore, that free electron pair is more reactive. We can notice that already by the fact that if we treat this aniline with an acid HX, we will get an ammonium salt like this. And the same is the case in reactivity for the reaction with acetic anhydride, abbreviated as this AC2O. How does the reaction take place? Well, it's an addition-elimination reaction. The nitrogen with a free electron attacks the electrophilic center, the carbonyl group, an addition process to this ionic intermediate with a negative charge at that oxygen and a positive charge at the nitrogen. And now a fragmentation will take place. This oxide is delivering electron density. This carbon-oxygen bond is broken, and this oxygen will trap one proton. And finally, we are getting to this paracetamol plus acetic acid. So we have a high selectivity a very high selectivity for the acylation of the nitrogen, but high selectivity does not mean 100% selectivity. What about the acylation of the hydroxy group? Sometimes it will also take place, at least if we have this acetic anhydride in excess. So let us think about a second acylation takes place, leading to this molecule with a carboxylic amide on this side of the molecule and an phenolic ester on the other side. A phenolic ester is rather sensitive towards hydrolysis. With a bit of sodium hydroxide in water, we will achieve that hydrolysis, while hydrolyzing a carboxylic acid amide is in need of very vigorous reaction conditions. Thanks for listening.